We physicists have held up 100 years, starting around 1916, for this photograph. It is a region dim openings might just be one of the most enrapturing and perplexing characteristics in the universe. They are enormous beasts regarding power, and however essentially imperceptible to us, a dull opening weighing maybe 2 to 4 multiple times the mass of the sun. Yet, as a result of the exploration that was put into them over the last several numerous years, we've gone from knowing in a real sense nothing about them to getting to find out increasingly more extremely close. And keeping in mind that things have simply gotten more crazy, Kaku as of late reported that we at long last got a gander at what's inside a dim opening. This new information conveys light to the nuances the universe of science might have missed from the very outset. Go along with us as we dig further into dim openings and unveil what's inside. Space colossal are dim openings. Before we get into the subtleties of what Kaku found, we want to examine the primary. In spite of the way that most of us have some thought what dull openings are, there are as yet a couple of openings. Legitimized data, you see, in 1916, Albert Einstein distributed his hypothesis of general relativity, which anticipated the presence of dim openings. At that time, the idea of dull openings was simply speculative. It required an extra 50 years for the logical local area to track down proof that dull openings really exist. This happened in the 1960s. They were examining the Cygnus star group when they saw an oddly astonishing blue star that was transmitting X-beams. This star was not an old item. However, was surrounding around a Goliath dim something. Upon additional assessment, it was seen that the X-beams weren't simply moving around all alone, however, they were being sucked into the dull thing they were surrounding. Thus the name dim opening. This revelation was critical in light of the fact that it gave proof that dim openings as a matter of fact exist, and that they were not simply a creation of Albert Einstein's wild creative mind. While that was extraordinary, it likewise intended that there was this fantastic element in space that we needed to find out about. So scientists from around the world got to work. This dark hole opening was named Cygnus X1, and it is situated in the star bunch Cygnus, around 6,000 light, a very long time from Earth. And it was no little disclosure. It's numerous times more splendid than the sun and unusually thick, which makes it have extreme areas of gravity. The gravitational post areas of strength for is such an extent that not indeed, even light can escape from it. This is why it is known as a dull opening. The idea of a dull opening is both fascinating and it is a startling locale of room where gravity is solid to the point that nothing, not indeed, even light can get away from. Whatever gets as well near a dim opening will be moved into it, gone perpetually. However, that piece of risk makes it considerably more critical to learn all that there is to be aware of them. Was this it? Or were we just starting? The response turned out to be the last option. After the disclosure of Cygnus X1, researchers started to search for other dim openings. They found that there might be close to more than 100 million dull openings in the smooth way alone. But since they are so incredibly difficult to distinguish, we still try not to have an accurate number. However, from its energies, there are several million dull openings in the smooth manner, in our very framework, which makes them considerably more vital to concentrate. So we should break it down. The principal worry with dull openings is continuously going to be gravity. Their gravitational draw is serious to the point that anything that enters it gets pressed down, cosmetically, until it turns into a peculiarity. In more straightforward terms, dull openings are like grandiose vacuum cleaners that suck everything in. One of the most alarming parts about the examination that has gone into dim openings is the way that if somebody somehow managed to fall into one, they would get sucked in until they become a solitary line. This cycle would happen gradually, and the individual would kick the bucket before the last structure truly sets in. So let's simply say that nobody ought to step into one. But they're all over the place. So at any point might we truly be in harm's way? Notwithstanding, despite the way that the nearest dim opening to Earth is around 500 light-years away, it's still sufficiently close to raise various types of reactions. In 2021, researchers had the option to create the first clear photograph of a dull opening, explicitly the M87 dull opening. This dim opening was shot several nights in progression, and with every photograph, the experts accumulated to increasingly verification about it. They needed to fasten the individual photos together to make something that filled every one of the holes. This way, they had the option to sort out that there are 3 layers to a dim opening. It's not only one single, growing opening of nothingness, as many individuals accept. Things are substantially more convoluted than that. To try and get to the nothingness part of a dull opening, you need to make it through the initial 2 layers. The first layer is known as the occasion skyline, while in the primary layer it's the point of no return. Once you pass the occasion skyline, there's not a chance other than straight ahead, and you will be sucked into the dim opening. And the 3 layers just deteriorate from that point forward. The subsequent layer is the photon circle, which is the locale where light circles the dim opening. Any light that enters this area will be caught and can't get away from the dim opening's gravitational power. At long last, we come to the 3rd layer, which is the peculiarity. This is where all that enters the dim opening gets stuffed out astronomically until it turns into a peculiarity. The peculiarity is a point in spacetime where the laws of physical science, as we probably are aware them, separate, and we can't anticipate what occurs next. At the peculiarity, the thickness is limitless, and the laws of physical science, as we probably are aware them, quit existing. Now, what makes this even more awful is the way that each and every dull opening you study will be totally not the same as the last. Certain they, as a matter of fact, do generally follow a similar 3-layer idea, yet the manner in which they work could be vastly unique. As of now, if this were anything more, all we'd have to do is bounce back on those telescopes and simply concentrate on the primary concern exhaustively. However, with dull openings, you can't actually do that. Researchers can concentrate on dull openings by implication by noticing the radiation they produce and the gas and residue that encompasses them. Sending a test like the Explorer into a dull opening is unimaginable since anything that enters the occasion skyline is pulled towards the peculiarity, where it is packed to an immensely little point. So you can't truly squander billions of dollars just to get a perusing each time in light of the fact that the second the test draws near enough, it'll simply pulverize into nothingness. In light of that clear issue, researchers are left with no decision except for to concentrate on study these objects in a 2-layered way, even though they are 3-layered characteristics in genuine reality. To make matters considerably more testing, there are likewise the 2 issues of each and every dim opening being novel and the laws of material science as we probably are aware them separating at the moment that we attempt to study the inside. This implies that the conventional strategies for logical request don't truly apply to the investigation of dull openings. That doesn't imply that the specialists haven't been occupied. There are heaps of various hypotheses and clarifications of dim openings. And well, with every one, things get increasingly fascinating. One of the most convincing speculations about the arrangement of dim openings is that they are produced using imploding stars. When a star all exhausts its fuel, it can no more produce sufficient energy to neutralize the power of gravity that is continually pulling internal. Accordingly, the star starts to fall in on itself, becoming increasingly dense as it does so. If the star is monstrous enough, this cycle can happen until it turns into a peculiarity. To comprehend the idea of dim openings in passing, NASA researchers coordinated their center towards the focal point of the world M87. Space experts saw a truly impressive whirlpool of extremely hot hydrogen gas that was turning at a surprising rate of 1.2 million miles per hour. The sheer power of this turning circle of gas ought to have made it stunningly fly-separated all over. Yet it didn't. Scientists reasoned that there should be a monster mass gathered at the focal point of the universe to forestall this from happening. This monstrous object weighed as much as 2 to 3 billion suns and should be a dull opening. But that's not the only hypothesis where dull openings turn. In 1963, the New Zealand mathematician Royer utilized Einstein's conditions of gravity to give the best portrayal of a turning dim opening. Kerr showed that a turning dull opening wouldn't collapse into a point as recently thought but to a ring of fire or, on the other hand, a meager plate. The circle would be turning so rapidly that radial forces would keep it from falling. This turning plate of issue is known as the ergosphere, and it is the region encompassing the dull opening where the regulations of physical science start to separate. However, the most intriguing component of dog arrangement was that it anticipated the presence of an Einstein-Rosen extension, otherwise called a wormhole. This is a hypothetical entry through spacetime that interfaces 2 separate regions of the universe or even 2 equal universes. The thought is that, if one somehow managed to fall into a dull opening, rather than being squashed to nothingness, One would be sucked down a passage through the ring of fire and catapulted out a white opening in an equal universe. To sort out how this functions, we really want to investigate the idea of spacetime. In Einstein's hypothesis, the realities are not discrete substances but are interconnected, forming a four-layered texture called spacetime. Objects with mass twist this texture, making a gravitational field that makes other objects move towards them. Presently, envision a piece of paper addressing spacetime. If you put two focuses on the paper and draw a spacetime, however, consider the possibility that you would be able to overlay the paper straight and make an alternate way between the two focuses. This is the fundamental thought behind a wormhole. It's an alternate way through spacetime that associates two far-off focuses in a moment. Wormholes aren't simply a sci-fi idea. They are really an assumption of general relativity. Although nobody has at any point noticed one straightforwardly, the reason is that wormholes are innately unsteady and would fall rapidly. However, the presence of an Einstein-Rosen extension would imply that dull openings are inestimable vacuum cleaners as well as could likewise be entryways to different areas of spacetime. So, could we utilize a wormhole to go through reality? Unfortunately, the response is most likely no, not yet. Anyway, regardless of whether we would be able to stabilize a wormhole, it's impossible that we could utilize it to travel quicker than light. Einstein's hypothesis of exceptional relativity predicts that the speed of light is a flat-out limit on how quick anything can travel through spacetime. However, the possibility of wormholes and dull openings as pathways to different pieces of the universe or even to various times has been a subject of interest and hypothesis among physicists for quite a long time. The possibility that there might be alternate routes through the texture of spacetime permitting travel through huge distances or even into the past may be progressive if we could really accomplish it. The crossbreed wormhole is one of the most interesting thoughts around here of study. It is named after the mathematician Royer, who first depicted Einstein's conditions of gravity. This kind of wormhole is basically a hypothetical section through spacetime that could associate two far-off focuses. For example, two distinct universes or even two unique times inside a similar universe. The hybrid wormhole is ring-formed, like the looking glass in the story of Alice, to a world where creatures talk in enigmas, and rationale didn't be assured to apply. Going through the hybrid ring could, as a matter of fact, transport a voyager to another universe or later where the laws of physical science might be totally different from those we have a lot of experience with. However, the idea of wormholes for the purpose of interstellar travel or time travel is positively energizing. As we've referenced before, it's likewise a subject of dispute and discussion among physicists. Some have called attention to that wormholes, and particularly mongrel wormholes, might be unsteady or troublesome to explore because of the serious radiation and subatomic forces surrounding their entrance. The pundits contend that Einstein's conditions of gravity, which are utilized to portray wormholes and dull openings, just work for gravity and not the quantum powers that administer radiation and subatomic particles. To genuinely figure out the idea of these irregularities, another hypothesis is required that can blend the laws of gravity with a quantum hypothesis of radiation all through the universe of science. This is known as a hypothesis of everything, a solitary hypothesis that can consolidate both Einstein's hypothesis of gravity and the quantum hypothesis. Michio Kaku, who's a renowned hypothetical physicist, has been dealing with a hypothesis of everything for a long time too. While there are loads of various renditions of what this could be, the one that has shown guarantee is superstring hypothesis. Superstring hypothesis binds together Einstein's hypothesis of gravity with the hypothesis of radiation. The hypothesis proposes that subatomic particles are really small vibrating strings, and that the universe is a symphony of these strings, similarly as various melodic notes compare to various vibrations of a violin string. Various particles in nature relate to various vibrations of a superstring. One of the intriguing things about superstring hypothesis is that as a string moves in time, it twists the texture of room around it, creating dim openings, wormholes, and other fascinating arrangements of Einstein conditions. This really implies that superstring hypothesis not just binds together Einstein's hypothesis of gravity with the quantum hypothesis, however, it likewise makes sense of a considerable number of the puzzling abnormalities that we see in the universe. However, there's a trick. The additional elements of spacetime that superstring hypothesis requires are little to the point that we can't actually notice them straightforwardly. The most reliable estimations that we can make in our labs just utilize the four aspects of spacetime that we know all about: length, width, profundity, and time. So, How might we at any point even know that the extra aspects exist? One chance is that the additional aspects are nestled into firmly that they are undetectable to us. Another chance is that the extra aspects were more obvious at the start of the universe during the Large Bang. As indicated by certain adaptations of superstring hypothesis, the universe started in a condition of 10-layered spacetime, with every one of the aspects similarly evident. As the universe extended and cooled, the additional aspects started to fall and twist up, leaving us with the 4 aspects that we notice today. If the situation is right, then we might be capable of identifying hints of the additional aspects around us. The math engaged with superstring hypothesis is amazingly perplexing. It has opened up totally new areas of arithmetic that were previously ignored. However, the test of tackling the issue of a quantum dull opening has demonstrated to be a slippery one. While numerous physicists have endeavored to tackle this issue, nobody has yet been ready to do so. Edward Witten of the Organization for Cutting-Edge Learn at Princeton has called superstring hypothesis 21st century material science that fell inadvertently into the 20th century. Last year, several gatherings of physicists freely reported a huge advancement. They tracked down that string hypothesis could totally settle the issue of a quantum dull opening, although just in 2 aspects, not 10. Numerous physicists accept that it's just a matter of time before somebody breaks this issue, given that the circumstances involved are positive if hard to address. Up to that point, it's still too soon to purchase tickets for intergalactic travel or time-traveling adventures. However, when it comes to dull openings, with the entirety of this, one thing is clear. There are simply such a large number of questions and shockingly more responses to these issues. Kaku's string hypothesis puts another curve on it all. Maybe the huge explosion wasn't exactly as large later. All he says it was anything but a huge blast, as many would normally suspect. It likewise didn't make a boisterous commotion like one could anticipate from a bang. The theory of the universe's origin doesn't give an clarification for what caused the affirmed bang or how it happened. It basically states that it happened. We want a hypothesis that can represent what occurred before the huge explosion. This is where string hypothesis comes in. According to this hypothesis, our universe could have been framed from the crash of 2 separate universes, or it could have risen up out of another universe like a youngster being brought into the world from its mom. This association between universes is known as a wormhole, which resembles a cylinder. It associating 2 bubbles is conceivable that we might have previously tracked down proof of this umbilical harmony that associated our universe to one more. In a manner, we could simply be living inside a dull opening this entire time, yet not have a clue about a thing about it since we exist in 4 aspects and can't see anything beyond. Conceivable we're in a dull opening also, and the dull openings we're considering are as a matter of fact wormholes to these other aspects.